We know that the sum of the internal angles of the triangle is 180 degrees, of the quadrilateral is 360 degrees, of the pentagon is 540 degrees. But what about the sum of the external angles of the triangle, of the quadrilateral, of the pentagon, of the hexagon, and in fact for any polygon? What will be the sum of the external angles of the polygon? Let's begin with the triangle, with a triangle. In this figure, we have a triangle, and let's name the vertices as A, B, and C. Let's quickly name these internal angles as angle 1, 2, and angle 3. And let's quickly name the external angles as X, Y, and Z. Okay. Now, let's begin with vertex A. X plus angle 1 is what? Is actually equal to 180 degrees, right? Therefore, angle 1 is equal to 180 degrees minus X. Okay? Let this be equation 1. From vertex B, y plus angle 2 is equal to 180 degrees. Same as in this case, these are actually what? Linear pair. This is also linear pair. Therefore, this will be equal to 180 degrees, right? Due to linear pair. So from here, you get angle 2 is equal to 180 degrees minus y. Similarly, for this angle 3 plus angle z, so angle z plus angle 3 is equal to 180 degrees, and from here you get angle 3 is equal to 180 degrees minus z. So let this be 2 and let this be 3. Now tell me, what will be angle 1 plus angle 2 plus angle 3? So this is actually what the sum of the internal angles, and this will be equal to 180 degrees, right? 1, 2, and 3 is equal to 180 degree. Now put the value of angle 1 from here. This is 180 degrees minus x, plus for 2 it is 180 degrees minus y, and for 3 it is 180 degrees minus z. This is equal to what? This is equal to 180 degrees. From here, this is 180 degrees plus 180 degrees, 360 degrees, plus 180 degrees is equal to 540 degrees. So 540 degrees minus x minus y minus z is equal to 180 degrees. Now we can write this as 540 degrees is minus x plus y plus z, because when you open the bracket this becomes minus x, minus y, and minus z. This is equal to 180 degrees. From here, if you transpose this minus x plus y plus z to the right hand side, and at the same time if you transpose 180 degree to the left hand side, you get 540 degrees minus 180 degrees is equal to x plus y plus z. From here you get x plus y plus z is equal to 360 degrees. That is, the sum of the external angles of the triangle is equal to 360 degrees for any triangle. Okay? In this case, we have a quadrilateral, and let's quickly mark the vertices A, B, C, and D. Let's quickly mark the internal angles 1, 2, 3, 4, and let's quickly mark the external angles. Let this be X, Y, Z, and W, right? Now from vertex A, if you write x plus angle 1 equal to 180 degree, we can write this as 180 degree. Why? Because of linear pair. They form linear pair. Now from here you get angle 1 as 180 degrees minus x. From vertex B, y plus angle 2 is equal to 180 degrees, and from here you get angle 2 is equal to 180 degrees minus angle 2. Sorry, angle y. Let this be equation 2. Then from vertex C, z plus angle 3 is equal to 180 degrees, and from here you get angle 3 is equal to 180 degrees minus z. Let this be 3. And from vertex D, this was from A, from B, from C, and from D, you get same way, you get angle 4 is equal to 180 degrees minus W. Okay, so this is fourth one. Now tell me, what is angle 1 plus angle 2 plus angle 3 plus angle 4? This is equal to what? 360 degrees. The sum of the internal angles of the quadrilateral is equal to 360 degrees. From here, if you put the value of angle 1, this is 180 degrees minus x. Angle 2 is 180 degrees minus y. Angle 3 is 180 degrees minus z, and angle 4 is 180 degrees minus w, and this is equal to 360 degrees. 180 plus 180 plus 180 plus 180, this is 720 degrees minus, this is x minus y minus z minus w is equal to 360 degrees. We can write this as 720 degrees minus, and then within the bracket, x plus y plus z plus w is equal to 360 degrees. Because when you open this bracket, this minus x, this becomes minus x minus y minus z and minus w. From here, if you transpose this minus x plus y plus z plus w to the right hand side, and at the same time if you transpose this 360 degrees to the left hand side, this becomes 720 degrees minus 360 degrees is equal to x plus y plus z plus w, and from here you get x plus y plus z plus w as 360 degrees. That is, the sum of the external angles of the quadrilateral is equal to 360 degrees. We have a pentagon here, and let's quickly name the vertices. This is A, this is B, let this be C, D, and E. Let's quickly name the internal angles. This is angle 1, 2, 3, 4, and this, let this be 5. Let's quickly name the external angles: X, Y, Z, W, and let this be U. Okay, now from vertex A, x plus angle 1 is equal to 180 degrees. How? Due to the concept of linear pair. They form linear pair. Therefore, from here, angle 1 is equal to 180 degrees minus x. From vertex B, y plus angle 2 is equal to 180 degrees. So from this one we get angle 2 as 180 180 degrees minus minus y. From vertex C, you get z plus angle 3 is equal to 180 degrees, and from here you get angle 3 as 180 degrees minus z. From vertex D, you get W plus angle 4 is equal to 180 degrees, and from here you get angle 4 as 180 degrees minus W. In the same way, from vertex E, you get angle 5 is equal to 180 degrees minus angle U. Now, the sum of the internal angles of the pentagon says that is equal to 540 degrees. So angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 is equal to 540 degrees. And if you put the value of angle 1 from here, you get 180 degrees minus x. Then for angle 2, this is 180 degrees minus y. For angle 3, it is 180 degrees minus z. 4 is 180 degrees minus w plus 180 degrees minus u. This is equal to 540 degrees. From here you get 180 degrees plus 180 is 360, plus 180 is 540, and then plus 180 is 720, and from here you get 900. So 900 degrees, and minus x minus y minus z minus w and minus u is equal to 540 degrees. This can be written as 900 degrees minus x plus y plus z plus w plus u. This is within the bracket, because when you open the bracket, this becomes minus x minus y minus z minus w and minus u, and this is equal to 540 degrees. Now if you transpose this minus x plus y plus z plus w plus u to the right hand side, and at the same time you transpose 540 degree to the left hand side, this becomes 900 degrees minus 540 degrees is equal to x plus y plus z plus w plus u. If you solve this, this becomes x plus y plus z plus w plus u is equal to 360 degrees. That is, the sum of the external angles of the pentagon is equal to 360 degrees. In this figure we have a hexagon. Let's quickly name the vertices. This is vertex A. Let this be B, C, D, E and F. Now let's quickly mark the internal angles. Let this be angle 1, 2, 3, 4, 5, and let this be 6. And it's time for the external angles. Let this be X, this be Y, Z, W, U, and let this be V. Now starting from this vertex A, from vertex A you can see that angle X plus angle 1 is equal to 180 degrees because of linear pair. It's linear pair, it forms 180 degrees. So X plus angle 1 is equal to 180 degrees, and from here you get angle 1 is equal to 180 degrees minus X. From vertex B you get From vertex P you get y plus angle 2 is equal to 180 degrees because of linear pair, and therefore angle 2 is equal to 180 degrees minus y. Equation 1, equation 2. From vertex C you get z plus angle 3 is equal to 180 degrees. If you solve it you get angle 3 is equal to 180 degrees minus z. This is 3. From vertex D you get w plus angle 4 is equal to 180 degrees, and you get angle 4 is equal to 180 degrees minus w. 4. From vertex E you get u plus angle 5 is equal to 180 degrees is equal to angle 5 is equal to 180 degrees minus u. And from vertex F you get v plus angle 6 equal to 180 degrees, and this gives you angle 6 as 180 degrees minus v. This is sixth equation. Now tell me, what's the sum of the internal angles of the hexagon? It is equal to 720 degrees. Therefore we can say that angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 and plus angle 6, this is equal to 720 degrees, the sum of the internal angles. Now put the values of 1, 2, 3, 4, 5 and 6 from here. So you get 180 degrees minus x. For 2 you get 180 degrees minus y. Then for 3 you get 180 degrees minus z. Then for 4 you get 180 degrees minus w. Then 5 is 180 degrees minus u, and then 6 is 180 degrees minus v. It is equal to 720 degrees. 180 plus 180 is 360, plus 180 is 540, plus 180 is 720, plus 180 is 900, and plus 180 is 1080. So this is 1080, and minus x minus y minus z minus w minus u and minus v is equal to 720 degrees. Now this can be written as 1080 minus outside the bracket, then plus x plus y plus z plus w plus u plus v, and this is equal to 720 degrees. If you transpose minus x plus y plus z plus w plus u plus v, this whole to the right hand side, and at the same time if you transpose 720 degree to the left hand side, this becomes 1080 degrees minus 720 degrees. This is equal to x plus y plus z plus w plus u plus v. So this gives you x plus y plus z plus w plus u plus v. This is equal to 360 degrees. So the sum of the external angles of the hexagon is equal to 360 degrees. Now from this one, for the pentagon, then for the quadrilateral, and then for the triangle, we can clearly see that in each and every case we are getting the sum of the external angles of the polygon as 360 degrees. Triangle is a polygon, quadrilateral is a polygon, pentagon is a polygon, and hexagon is a polygon. In every case you are getting 360 degrees. It means that doesn't matter what polygon it is, whether it is 11-sided, it is 20-sided, or any n-sided polygons, the sum of the external angles will always be equal to 360 degrees for any n-sided for any n-sided polygon. For any n-sided polygon, the sum of the external angles will be equal to 360 degrees.